As long as you stay over here. Okay. Yeah, I know, right? I'm speechless. Don't give me a problem. Give me a solution. Alright, we got your 12.2. Okay, 12.3 next week. So 12.2. Okay. Any issues regarding 12.2? Any? Okay. Let's see 12.2. Question 3A and 3C. 4A. 5B. 6B. Question 8. Is it a partial fractions part? No. 8 part I is the partial fraction part. Yeah. They give you the form, that one is partial fraction. So 8 part 2 is it? Okay. Then question 9. Alright. So let me just go through 8 part 2 and 8 question 9. Then how you do part I?
I just do by comparison.
8 part I also. Okay, can. I'll just do.
I do by comparison.
I don't know how to do your comparison. Comparing coefficient. Can what? That's also partial fraction method what? Yes. Okay, let's look at question 8 first. Right? Exercise 12.2. Okay, so in part I, you are required to find out the value of A and B. Okay, this question itself, alright, already lent you a helping hand by telling you to actually give it in this form. It is not all the time that they will actually say to you this way. Alright, so in this kind of method itself is already partial fraction because you're putting it into different fraction partials. Okay. Technically, alright, when we move on to our quotient rule, now that we have been exposed to it, we don't really require our partial fraction to solve this question. Because if we look at this one, we can just apply our quotient rule and differentiate already. Just that this thing over here is falling under 12.2 where we have not yet looked at quotient rule. That's why the recommendation to do partial fractions. Okay, so in order to solve this, what we'll do is to multiply across by the biggest denominator. So that means that on the left side I'll be left with 2x minus 1. This fraction itself I will get A times x minus 1. This fraction itself I'll get B. Okay? So multiply across by x minus 1 squared. Then we will let x equals to 1 so that this becomes 0 and A disappears. So we get 2, 1 minus 1 equals to 0 plus B. So B is equals to 1. Then to determine A, you can use any substitution, right? Convenient one will be do 0. Okay, let x equals to 0. So 2 times 0 is 0, then minus 1 over here equals to A times negative 1 plus 1. B is 1. Okay, so we will get negative A equals to negative 1 and A will be equals to, hang on, sorry. A negative 1 minus 1. So A will be equals to 2. Okay, so that's how we solve A and B. Then in part 2, it asks you to actually make use of this and do the differentiation. So we let y to be equals to this, which is actually equals to 2 over x minus 1 plus 1 over x minus 1 squared. So your equivalence over here. Okay, which is 2 times x minus 1 to the power negative 1 plus x minus 1 to the power negative 2. Then dy over dx equals to 2 negative 1 x minus 1 negative 2 1 plus negative simplify negative 2 x minus 1 square minus 2 over x minus 1 cube. Right? So that's how you get the answer. Okay, so application of chain rule over here. Okay? You can combine, not an issue. If you were to combine it, you will get negative 2x minus 1 minus 2 over x minus 1 cube equals to negative 2x plus 2 minus 2, 0. You will get this out. Okay? It's fine if you combine it as well. Alright, but the question did not expect you to combine since they didn't actually give you a specific form to arrive at. Okay, next, question 9. They gave you the equation of this curve, and it said that they want you to find the coordinates of the point at which the gradient is 0. Okay, so gradient equals to 0. So we will first find the derivative. And we have this. Then since we know that the gradient is 0, so that means our dy over dx is equals to 0. So we proceed to solve. I will move my plus 1 over here, or rather this side I move here first. Equals to 1. So 2 minus 5x squared equals to 1 over 15. Okay, sorry. Oh, sorry, I differentiated wrong. This one no at plus 1. My bad. Okay. Yeah, differentiation of this, arrive at this one, then it's equals to 0. So this one equals to 0 will mean that 2 minus 5x itself equals to 0. No need to go and expand and start solving quadratic. Okay, because if you solve quadratic and now you want to factorize also go back to this, then you're just going one big round. Okay, so 5x is equals to 2, x equals to 2 over 5. We want to find the coordinates, so we will take x and substitute into the curve. So we find that y is equals to 1. Therefore, coordinates will be 2 over 5 and 1. Okay? What was the issue in question 9 that you all can't do? Amanda? Oh, you put the plus 1 also. Oh, okay. So, same careless mistake as me. Okay. Any other questions? Otherwise, could you submit your homework to the front? Then we will continue our 12.4, and hopefully we can go into 13.1 today as well. Okay, to go back and give exercise 12.4 question 2D a try, right? Did you all manage to give that a try? Yes or no? No. How many of you have not tried this yet? Okay, since that's the case, give this a try. Those who have already tried, I want you to do question 1A. 1B. 1C. 1D. And 2B. Okay, I give you about 15 minutes to give all these questions a try. Okay, hopefully I didn't make any mistakes on the board. Alright, I think for 2D, okay, if you were to look at the question, I hope that you are able to accept the fact that when we have a fraction in a fraction, okay, what we do in this step is we will bring this, the whole of the numerator to share that common denominator here, okay, so that this one multiply with this, so square root 3x squared minus 1 times this, I will get 1 full 3x squared minus 1. Okay, then what happens to this denominator is that I will combine it with the one over here, okay, the main fractions denominator, and multiply them together, okay, because of the concept that I shared the other day. Okay, then therefore at the numerator itself, I will be having 10x times 3x squared minus 1 minus 15x cubed. Okay, then I expand and simplify, I will be able to get 15x cubed minus 10x over 3x squared minus 1. Okay, am I right? Any questions regarding this? Alright, then for 1A, okay, for 1A, it will just be applying your quotient rule. Okay, you will need to expand the numerator and simplify it to arrive at this one here. Okay, so, yeah, okay, I got it correct here. Then for 1B, what I noticed when I walked around is that, okay, some of you already have it, okay, you found habit to actually see that when you have a square root, okay, it is actually a power of half, right? So you don't bother to write down, for example, in this case, you don't bother to write it in this manner, which is power half, okay, which is fine, alright? Just that, okay, when it came to this part, when you needed to go and differentiate, because over here, we kept the bottom, differentiate the top, okay? So this is a result of differentiating negative square root t. Then over here, it is a result of differentiating positive square root t. Okay, so you brought down the half, but then you forgot to minus 1. And then over here, some of you actually forgot to put in the power. And that will affect the answer greatly. Okay, so technically if you had been observant, you will notice that square root t's, they are both the same. So, strictly speaking, they should be similar. The difference that they had is just at the negative and the positive sign. Right? That's why this one has negative, this one is a positive. Okay, then after the process of simplifying, you could form a fraction for this term and the fraction for that term first. Seeing that they have the same denominator, you could bring it down to the main fraction's denominator such that you get 2 square root t times 1 plus square root t squared. Okay, be very careful that this negative sign is outside of the 1 plus square root t. So this actually means that it is a negative 1 plus square root t. Okay, that's why when I bring in the negative, I'm able to get this section here. Negative 1 minus square root t. Likewise, this is a negative brackets 1 minus square root t. Right? When I bring in the negative sign, it should be a negative 1 plus square root t. Okay, so these are common kind of algebraic mistakes, okay, that could be made. Then negative 1 gives us negative 2. Negative square root t plus square root t is 0. So with the negative 2 and the 2 in the denominator, I cancel that out. That's why I get negative 1 over square root t times 1 plus square root t squared. Okay? So when it comes to using quotient rule to differentiate, you've got to really spend the time, okay, to work on it. Right, Wena, can you wake up please? Okay? So please don't rush into it. Right? Then for 1C, okay, do you all get this same answer? Sorry? Oh, sorry, I must have sent something wrongly. I think I saw this too. Thank you. 4, right? Yeah, okay. Okay, do you have any mistakes in 1C? Alright, okay, you'll get the same answer. Then 1D, okay, I wanted to find out for 1D, how many of you did quotient rule? Quotient rule? Okay, I mean since you have a copy of quotient rule, I believe you would have done quotient rule for 1D. Okay, but I want to challenge you further. Is there a simpler way to solve for 1D rather than to use quotient rule? What can we do to solve 1D if I don't want to use quotient rule? You do find quotient rule can be a complicated process, right? So what can we do to quotient to this? When you like got answer. Yes, Wena. Divide. So meaning to say, divide individually, yes. Okay, so I can take a squared divided by square root a. So I simplify. I split out the entire fraction, okay, into 3 different terms, right? So that would be more manageable than to do quotient rule. So meaning to say something like that. Okay, and this is only possible if there's only one thing in the bottom, okay, one item, and then after having the same base. So in this case, I will be getting 2 minus away half, so that will be 3 over 2, 1.5. So to a to the power of 1 minus away half, I will get a to the power of half. Okay, so I'll get to express it in this form. Then over here, you just use the power rule. Okay, so dr over dA. Okay, because we're talking about r and a, so that's why we have dr over dA. So we get 3 over 2a half plus 2 half a negative half minus 7. We continue here. Negative 7 negative half a negative 3 over 2. Okay, and then you could simplify it. Do you have any mistake? 1b. Now wait, I finish this out first. Okay, so we will get, as we say here, 3 over 2 square root a plus 1 over square root a plus 7 over 2 a to the power 3 over 2. Okay, so you may find that this will be more manageable, less complicated than if you want to do quotient rule. But if you do quotient rule, your answer should more or less still be similar, just that most likely you combine it into one single fraction. That's all. Wait, now you were saying about 1b? Don't have any? Okay. Any questions? Right? So now let's look at 2B. Okay, so for 2B we have no choice but to apply our quotient rule. So keep the bottom, differentiate the top, minus keep the top, differentiate the bottom. Okay, so you arrive at this when you leave it into positive index form. Take the denominator, multiply to the 1 without denominator. So I'll get 2 bracket x minus 1 because square root times square root becomes the whole. And then minus away x over 2 square root x minus 1 times x minus 1. We can simplify, expanding it, I'll get 2x minus away x, I'll be left with 1. And then minus away 2. You can definitely combine the square root x minus 1 with the x minus 1 to write it as x minus 1 to the power of 3 over 2. That is fine as well. The answers from earlier? Hannah? Okay, now let's take a look at question 8, where in part I, the question asks to differentiate 1 minus x squared times square root x plus 3. And in part 2, they said that to use the quotient rule to find the rate of change of y equals to this with respect to x when x equals to 1. Okay. When we go into chapter 13 or 14, I don't quite remember the number, sorry. We will be touching on rate of change. Okay, I find that the use of the rate of change in this question is a bit confusing with what we're going to talk about later on. Because usually when we talk about rate, right, okay, we compare it with time. Alright, but in this question, okay, we want to just refer it to gradient. Okay, so what the question is asking for is really just the gradient. Why would they have such a phrasing for it? It is because when we talk about dy over dx, okay, we link it with gradient. And when we think about gradient in our Emaths terms, okay, we are looking at the gradient itself to be y2 minus y1 over x2 minus x1. Okay, and how we interpret it, alright, in a quantitative manner is that y2 minus y1 is what we see as the change in y. Because it's a difference, and x, the difference for x over here is what we see as change in x. Okay, so if dy over dx is another form of gradient, and gradient by definition, by formula is expressed this way, and understanding it in words term, right? Okay, it is change in y over change in x. That's why, okay, we can say dy over dx is a change in y over change in x. And that is the reason why they use such a term, rate of change. Okay, so these are different ways, right, to see and understand our dy dx itself. Okay, because it's not always about gradient. Gradient is a very specific to the quadratic curve itself. If there's a context given, then we're actually talking about changes, right? So that's why we have such a term. Okay, so I'd like you to do part I first. Okay, using product rule, could you just differentiate this? Give you about 1 minute. You can do it in 1 minute. You need more time. Give you another minute. Are we done? Okay, so what is your answer? What do you get? Wait, you look like you're done. One minus x squared bracket, let's bracket half, bracket x plus 3 to the power of negative half, then plus, sorry, of x plus 3 brackets power of half and negative 2x. Anything else that you'd like to add? No? Anything else that you'd like to add for the rest of the class? This is after applying the product rule, so it's in this very rough form. Yes, Emily? Okay, yes, missing brackets here for 1 minus x squared. That's very important. Otherwise, you will give a different meaning to the question itself. Okay, so we keep left, differentiate right. Okay, keep right, differentiate left. So this is accurate application of your product rule. Then we can simplify this. Alright, so we will get 2 square root x plus 3 in the denominator. In the numerator, we have 1 minus x squared for the first part. And in the second part, we can have negative 2x square root x plus 3. Okay, so we tidy it up, right, to write it in this manner, in positive index form, right? This tidier version is helpful when we want to do part 2, okay, where we want to find the gradient when y is equals to this with respect to, and want to differentiate, okay, with respect to x when x is equals to 1, alright? So if I want to use my product rule in part 2, let me just write it out first. Square root x plus 3 over x cubed. Using my product rule will tell me that I need to keep x cubed first and then differentiate the numerator. Please don't go back to differentiate the numerator again when you have already done it in part I. Okay, so that's the reason why part I is actually given. Right, so you just use your answer in part I, okay, as a derivative of your numerator. So we would get 1 minus x squared over 2 square root x plus 3 minus 2x square root x plus 3. Okay, so keep bottom, differentiate top, then minus away the top, keep the top, differentiate the bottom, we get this. And in the denominator, x cubed, got to square it. Okay, and at this stage, you find it in a very, very messy manner. So that's why when you do quotient rule, a lot of focus is required. Okay, so let's start on it. What will the next step be? What will you do? Anson, want to give it a try? How will you start off? Let's do it bit by bit. No need to do anything massive. Cancel out, sorry, which one? X to the power of 3. This one here, cancel out. Can we do that? But down here to have x to the power of 3. Expand this one first. You sure you want to do that? Expand this one. You sure you want to do that? It looks like it's going to be a mess, isn't it? Yeah. Think we don't want to risk that. Okay. Any other proposals? No? Okay. Now mind, go try. Alright? Anybody else? Alia, what do you think? Let's try to keep this tidy and then avoid expanding. Yeah. Yeah. For you lah, cause your handwriting.
So my handwriting ready.
I guess it's relative, yes. Alia, what would you try to do first? We got the square root in the denominator, right? So if you think back to how we were doing our quotient rule with square roots in the denominator, likely, okay, if there's a fraction within a fraction, we want to end up bringing it down. And in order to bring it down, everything on top must share the same denominator first. Right? Okay, so let's just start on that by making the things in the numerator having a shared common denominator. Okay, so let's start on that. Okay, let's keep the x cubed outside. Let's just do part by part. Let's do the things inside this bracket. I will have 1 minus x squared. Not enough space. Equals to x cubed. Okay, 1 minus x squared minus 2x square root x plus 3. 2 square root x plus 3. Okay, I multiply it up. Then I have this. I leave this stuff untouched. Okay. Denominator, what does that simplify to? What is x cubed to the power of 2? X to the power of what? 6 or 9? 6, okay. So 3 times 2, 6, okay. Then, let's try to simplify this first before we do anything further. 1 minus x squared minus away 2x. These are all multiplication, yeah? 2x times square root x plus 3 times 2 times square root x plus 3. So 2x times 2 give me 4x. Square root x plus 3 times square root x plus 3 will give me x plus 3. So at least we have shortened things by a little bit. Okay, I'll erase inside, yeah? Then, let's simplify this numerator further. I'll get x cubed. Technically, because it's a multiplication, I can bring it up to the numerator, so I'll just x cubed 1 minus x squared minus 4x squared minus 12x over 2 square root x plus 3 minus away. Let me just rearrange this bit. 3x squared 1 minus x squared square root x plus 3 x to the power 6. Okay. This one gives me a 1 minus 5x squared minus 12x minus away. I can now bring this denominator and stretch it over to the other one. So I have 3x squared 1 minus x squared square root x plus 3, and I multiply with a 2 square root x plus 3. Okay, so I extend it over already. The whole thing here now shares that same denominator, 2 square root x plus 3. So since now everything has that, I can bring it down. 2x power 6 square root x plus 3. Okay, so I'm skipping a few steps over here. I hope you managed to catch what I was saying. Alright. Repeat myself, I took this fraction here, extend the denominator to the second term, which is the reason why I have this. Then I can have that condition to bring it down. Okay? So therefore I have this up. Yeah. Did I make a mistake? Where? Sorry? This thing? The whole thing? Why? This whole thing divided by x power 6. Then you want to simplify that here. Then I need to break it into 2 fractions. This one I need to have it over x power 6. You are saying this thing divided by x power 6, right? Yeah. Okay. Then you can. Then down here also need to divide by x power 6. What's your question? Am I not understanding your question well? You want to simplify, is it? You can. So x cubed and x power 6 cancel. But the x power 6 still maintain this one. It's like, give you a number. 2 over 3 over 6 minus away 7. Okay? This actually means 2 over 3 over 6 minus 7 over 6. So 2 over 3 over 6 will give you 1 over 3 times 3, 9 minus 7 over 6. When you cancel like that. Right? Okay. So I don't recommend doing that. You'll be having 2 fractions. Okay? If you don't understand what he was asking, never mind. You understand this one can already. Okay? Any questions so far? Yes, Anson. Where did the 2, this one come from? It is because, if I use this example, yeah, okay, I will 2 over 3 minus 7. I make them same denominator. 2 over 3, I must minus 7 times 3 over 3, right? Then over 6, huh? See, I times 3, right? So, my 3 actually is this one. Okay? So that now I can actually extend my fraction line and have only 1 3. You understand? Then after that, right, because it's whole fraction here, divide by 6. Okay? So in other words, it means divide by 6. So divide by 6 means times 1 over 6. So fraction times fraction, numerator times numerator, denominator times denominator. So 3 times 6. So that's why I have this. So I took this and this, put them together. Okay? Anybody not following? Right? Continue, yeah? Okay, from here, I will have x cubed. I will not expand it, okay? Because this one I won't expand and simplify this also, right? I think, let's try. This square root and this square root times together. Okay, and then have this 2x power 6 square root x plus 3. Okay, then yeah, I get for my final answer. Oh, sorry, I lost track of what we're trying to find. We're not trying to simplify this, right? We actually want x equals to 1, right? Yeah. So actually, this one is just to train you in your simplification process. Okay? But in exam surely also got this kind of challenge one, alright? You need to practice also. Okay? I tell you, if the exam give you part 2, do this, find dy over dx, simplify. Then part 3 asks you x equals to 1. You got no choice, but you also got to do this. Correct or not? Okay? So no choice, you still have to run through this kind of patience. Okay?
So you say not messy, isn't this messy?
Yeah. Yeah.
So actually say make it not messy, make it tiny.
But it's better than if I expand this as per what answer was saying, right? He wanted to expand this, You try lah. Yeah. Now I do it and you copy only, Yeah. I'm doing the tough work, you know. Yeah. Okay, so continue. So at this point, if you want to, you can go and simplify this out. Okay, you can expand, simplify. You can go ahead do it. But this is slightly neater looking now. Alright. Okay. Then after you put in the x equals to 1. Alright. Just press calculator. Okay. I don't need you to go and put in the substitution. 1 cube, 1 minus, and then all your 1, 1, 1, 1, 1. Alright. Okay, it's just going to worth 1 mark, alright, which is the final answer. As in, the final answer worth 1 mark only, okay? So go and put into calculator, alright? When x equals to 1, dy over dx, what do you get? Negative 4. Alright, you put inside here, you should also get negative 4. Yes, you can put in from here. You can put it from here. Okay? But you never know what your exam will test you. Correct or not? Okay? So you train your patience. You cannot reject. If the exam comes out like that, you got no choice. Okay? And this is an easy mark to get. Alright? This is just procedural. Yeah, apply formula, simplify, expand. Not asking you to figure out what the question is saying. Okay? Right? So please make sure you train your patience. Okay? Get negative 4. What time my lesson end again? 40 okay, so that means. No. Yeah. It's not fine. Okay? Okay, any questions? Anna? Okay, one last one.
Do it. Copying you, huh? Nothing. Nothing. Oh shit.
Calculate the radius of the Let me think. We don't want to give you this question. Four. Okay lah, advanced test of patience. Okay, but if you want to go and train your patience further, you can go and try exercise 12.4 question 10. Okay, I'll just say it. Alright, if you want to test your patience, this one they gave you this. Okay, my challenge to you is to differentiate this, simplify, and see if you can arrive at this or not. Okay? So, you can go back home and go and work on it yourself. Right? If given y equals to this, right, you can bring down the power, then after this whole thing, 4 become power of 3, right, minus 1. Then you need to differentiate the inside using your chain rule. Differentiate inside, okay, is using your quotient rule. So it's a lot of things to do, okay? So my challenge to you, go back home. If you got the patience, which you should train, alright? See if you can arrive at this, okay? It's your classwork, as in at your own time work, okay?
So eventually you'll collect, right?
I will not connect, okay? But this is just my challenge to you. Go and train your patience. For Joseph, he will train your handwriting also, okay?
My handwriting cannot change one.
Can.
Cannot change one.
Alright, so with that, right, okay, 12.4 we are done, okay? So, homework for
Oh my god! Let's go, homework!
this one lesser. Question 2A, C, 5 and 7, that's all.
I thought it's still question.
Okay, your student.
I see nothing.
Hey, homework.
I'm sure I give lesser homework than some other teachers, okay?
Sure. You're the only teacher who gives homework every lesson, more or less.
Because you take E-Maths and A-Maths, you see me 2 subjects, right? You must remember that, no. You are taking 2 subjects with me, not 1 subject. Okay? Could I erase this?
Quotient deadline is 12.2.
So 12.4 deadline, no lah. Don't want to be same deadline. You die, I also die. The next day long, 4th February long. Okay, I erase this, yeah? You want to copy? Negative 15, 5x plus 3, or 3. And? Done, huh? Okay, 13.1. Yes. Okay, chapter 13, we are going to be looking at tangents, normals, and rates of change. Right, 13.1, we are going to learn how to actually form the equation for tangents and normals. Okay, so let's just do a very quick recap about what is a tangent and what is a normal, right? So, in a graphical manner, okay, if I have a curve, okay, so let's say y equals to fx. Okay, you'll be overnight thing. Okay, with the pathetic 5 views that I get from video. Don't know who will be watching. So, y equals fx, curve. Tangent is one line. touches the curve at one point only. Okay, that touches at one point. Then we have this thing called a normal. Are you okay, Joanne? Yeah, we got pretty sweet already. Okay, on normal, right, is where it is perpendicular to the tangent. Okay? So, the gradient of the tangent, we have actually earlier talked about it, and that is actually the dy over dx. So, gradient will be our dy over dx, or in another notation will be our f prime x. Okay? Whereas for normal, because it is perpendicular, okay, our gradient of the normal, right? Perpendicular lines, when gradient multiplied by each other will become -1. So the gradient of normal will be -1 over the dy over dx, or in other words, -1 over our f prime x. Because of the idea of perpendicular. Okay? Since both of them are lines, okay, they will fulfill our y equals to mx plus c. Right? And with the gradient, okay, it will at least fulfill the m part. Okay? And for the c part, we are just going to make use of the point that we will know. Alright? Okay, let's look at try one. Guys, you're okay? No, but too bad. We still have to continue. Okay. So try one, right? We are given this information. Okay. Given a cubic equation, and then we have 2 points A and B. Over here, this one we are given the tangent, and then we are given a normal for the one at point B. In part I, we want to find the equation of the tangent at A. And in part 2, we want the equation of normal at B. And in part 3, they want the equation of the normal at where the curve intersects y-axis. Okay, I think I probably only can do part I or part and maybe part 2 today. So let's look at part I first. Where we want to find the equation of the tangent at A. So since we're given the equation of the curve, I can do my differentiation to determine the gradient, okay, of the tangents at the curve itself, on the curve itself. So the gradients of the tangents, any tangent that's going to be found on the curve will fulfill this equation. At the point A, I will get 12 12 plus 6, 18. Okay, so with the gradient to be equals to 18, and since we are given the point, okay, the equation of the tangent can be found by y minus away 15 equals to gradient times x minus 2. Okay, that is using your y minus coordinate, y coordinate equals to gradient times x minus x coordinate. And the equation of the tangent will be 18x minus 21. Okay? Then next one, to find equation of the normal. Since I already have the dy over dx, which is 3x squared plus 6, then we will look at the point B, negative 1, negative 12, and find that dy over dx equals to 3, negative 1 squared plus 6, which gives us 9. Okay. Now that we have the gradient to be equals to dy over dx equals to 9, how do we find the equation of the normal? What do you think we need to do next? Ning-Hui, what do you think? Is 9 the gradient of the normal? Is 9 gradient of normal? What do you think? Yes, no? You look at the summary that I have over that side. Is it here? Is 9 the gradient of the normal? No. So how do I find the gradient of normal? Sorry? Negative 1 over? Sorry, negative 1 over 9. Okay. So the gradient of the normal is always perpendicular to the tangent, so that's why I must get negative 1 over 9. Okay. So then I can proceed with finding the equation of the normal, which is y minus away the point, negative 12. So that's why I become plus 12. Gradient of normal, x minus negative 1. Minus 12. So y is equals to negative 1 over 9x minus 12 and 1 over 9. Okay? Questions? So this warms us up to find the equation of tangent and normal. Right? Next lesson we will complete our 13.1, okay, which is all that we need to cover for our WA1. Yes, of course. After each topic I give homework, right? And then you tell me you forget.